In this episode, we're going to focus on the step that turns raw telemetry into something an analyst can use quickly. Enrichment, which means adding context that makes events understandable, comparable, and actionable. New learners often believe that once logs are collected, the hard part is done, but in most real monitoring environments, the slowdowns come from missing context rather than missing events. An alert that says a login occurred is not very helpful if you do not know whether the account is privileged, whether the device is sensitive, whether the location is normal, and whether the behavior is unusual for that role. Enrichment is what fills in those gaps so that triage becomes faster and decisions become more confident, especially when the SOC is dealing with many alerts and limited time. It also reduces noise by letting detections distinguish normal business behavior from genuinely risky behavior, which is a major part of sustainability. By the end, you should be able to explain what enrichment is, why it matters, and what kinds of context deliver the biggest speed gains without turning the monitoring system into a confusing or risky data warehouse. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A clean way to define enrichment is that it is the process of attaching additional meaning to an event without changing the event's original truth. The original event might say that a user logged into a system, or that a process started, or that a network connection was made, and those are the facts recorded by the source. Enrichment adds facts that the source might not know, such as the user's role, the device's business owner, the asset's criticality, or the network segment's purpose. This matters because many security judgments depend on relationships, like whether the user should have access to that system, whether the system is a sensitive environment, or whether the connection destination is a known service. Enrichment also supports consistent correlation across sources, because different systems may label the same identity or the same host differently, and enrichment can help unify those identities and assets into a consistent representation. For beginners, it helps to think of enrichment like adding labels and background notes to a map, because the roads are still the same roads, but now you know which roads lead to a hospital, which roads are closed at night, and which roads are commonly used. That extra information makes navigation faster, and the same idea applies to investigations. The first enrichment category to cement is identity context, because most investigations quickly become questions about who did something and whether that person or account should have been able to do it. Identity context includes role, department, privilege level, and whether the account is a human user, an administrator, or a service identity used by automation. It also includes risk signals such as whether the account is newly created, whether it has recently changed privileges, or whether it is tied to a sensitive function like payment processing. Without identity enrichment, analysts can waste time looking up basic facts, and detections can misfire by treating all accounts as equal. Identity enrichment also helps you reason about normal patterns, because different roles have different working hours, different access needs, and different expected geographies. Even a simple event like repeated login failures becomes more meaningful if it involves a privileged account rather than a temporary user. When identity context is consistently attached to authentication and access events, triage becomes decisively faster because analysts can immediately see whether an event involves a high-risk identity. The second major enrichment category is asset context, which is about understanding what a system is and how much it matters to the organization. Asset context includes business criticality, system owner, environment classification such as production versus testing, and the system's function, such as email gateway, database server, or development workstation. This context changes decisions because a suspicious action on a low-impact test system might be investigated differently than the same action on a production database holding sensitive data. Asset context also helps you build better detections, because you can tune thresholds and severity based on the importance of the target. For example, remote access to a system that should never be administered remotely is more concerning than remote access to a system designed for remote management. Asset context also supports routing and escalation, because knowing the system owner or responsible team helps the SOC communicate quickly during an incident. Without that, analysts might waste time figuring out who to contact while impact grows. When you enrich events with asset criticality and ownership, you reduce both investigative time and coordination time, which is why it speeds monitoring in a very practical way. Another enrichment layer that delivers big speed gains is network and location context, because many behaviors become suspicious only when you know where they originated and where they went. Location can mean geographic location, but it can also mean logical location, such as which network segment, which access channel, or which remote connection method was used. Network context includes whether an IP address is internal or external, whether it belongs to a known corporate range, whether it is associated with a trusted partner, or whether it is newly observed. It can also include whether a destination is a known service, a known update endpoint, or an unusual external host that rarely appears. This context matters because attackers often stand out through unusual paths, like access from an unexpected region or connections to unfamiliar destinations. For beginners, it is useful to remember that network and location context helps you judge plausibility, because a login from a normal office network is more plausible than a login from an unknown location, all else being equal. When detections can use this context, they can reduce false positives and surface truly unusual behavior more reliably. Analysts also benefit because they can quickly decide whether a connection pattern matches normal business operations. A powerful but sometimes overlooked enrichment category is time and behavior baseline context, which helps you distinguish an unusual event from a routine one. Time context includes not only accurate timestamps, but also business calendars such as maintenance windows, expected batch processing times, and normal peak periods like month-end closing. Behavior baselines include what is typical for a user, device, or service, such as usual login hours, typical access targets, and normal data transfer volumes. You do not need advanced mathematics to understand the value here, because the point is simply that normal is not the same for everyone. A backup service might move large volumes of data at night, while a normal user account doing the same thing might be highly suspicious. A system administrator might log into many servers, while a finance employee doing that could signal credential abuse. When monitoring includes baseline enrichment, analysts spend less time debating whether something is abnormal, because the context makes that judgment clearer. This is one of the biggest ways enrichment speeds monitoring, because it reduces indecision and unnecessary investigation. Enrichment also supports faster monitoring by enabling better correlation, which is the ability to connect related events across different sources into a single story. Correlation depends on stable identifiers, and in many environments identifiers are messy, such as different username formats, different host naming conventions, or different ways of representing the same device. Enrichment can normalize these identifiers by mapping them to canonical forms, such as a single user identifier or a single asset identifier that is consistent across systems. Once that mapping exists, a SOC can pivot quickly from an authentication event to endpoint activity for the same user, to network connections from the same device, to application actions in the same session. Without enrichment, those pivots become manual lookups and guesswork, which slows response and increases mistakes. Correlation also improves detection quality, because many meaningful behaviors are multi-step, and a single event in isolation might look harmless. For example, an unusual login followed by a privilege change followed by new outbound connections is far more concerning than any one of those events alone. Enrichment makes those links easier to build and faster to use. While enrichment brings speed, it also introduces responsibility, because adding context can increase the sensitivity of data and can introduce errors if the context is wrong. If you attach the wrong role to a user, you might escalate harmless events or ignore risky ones, which is why enrichment sources must be trustworthy and updated. If you attach the wrong criticality tag to an asset, you might misprioritize incidents and waste time. This is why governance matters, including controlling who can change enrichment mappings and ensuring changes are logged and reviewed. Data minimization is also important, because enrichment should add what is needed for decisions, not copy unnecessary personal or business details into the monitoring system. For beginners, a good rule is that enrichment should be the smallest set of context that makes decisions faster and more accurate, and anything beyond that needs a clear justification. Another key habit is to include quality checks, such as monitoring for missing tags, stale mappings, or sudden changes in identity or asset attributes. Good enrichment speeds monitoring only when it is reliable, so building trust in enrichment is part of building speed. A practical way to prioritize enrichment is to focus on context that reduces the first 5 minutes of triage, because that is where most alert handling time is spent. In those first minutes, analysts typically need to know whether the identity is high risk, whether the asset is critical, whether the action is unusual, and who owns the system. If enrichment provides those answers directly in the alert or event view, analysts can make quick decisions about severity, routing, and next steps. If enrichment is missing, analysts must search other systems, ask other teams, or make assumptions, which slows everything down and creates inconsistency. This is why identity role, privilege status, asset criticality, and ownership are often the highest return enrichment fields early in a program. Network classification, such as internal versus external and known versus unknown, also provides quick clarity for many use cases. Over time, you can add deeper enrichment like application-specific context and behavioral baselines. But starting with triage critical context delivers decisive speed improvements quickly. Thinking this way keeps enrichment from becoming an endless project and turns it into a targeted performance improvement. Enrichment also shapes how detections are written and tuned, because context lets detections be specific without being fragile. Without enrichment, you might have to use blunt thresholds, like alert on more than a certain number of failures, which can generate noise across many roles. With enrichment, you can set different expectations for different contexts, such as stricter thresholds for privileged identities and more tolerant thresholds for systems that naturally generate background noise. Enrichment can also enable consistent classification, such as tagging alerts by business service, environment, or data sensitivity, which improves routing and reporting. This matters because sustainable monitoring is not just about detecting threats. It is about managing work, and work management depends on consistent classification and prioritization. When enrichment is applied consistently, tuning becomes more effective because you can see patterns like which business units generate the most noise and which systems produce the most actionable alerts. Over time, this creates a feedback loop where enrichment improves detection and detection outcomes guide better enrichment priorities. That loop is a core part of making monitoring faster and more confident as the program matures. It is also important to recognize that enrichment must be integrated into the pipeline in a way that does not create delays or single points of failure. Some enrichment can be applied at ingestion time, attaching tags as events arrive, while other enrichment can be applied at query time, where the context is looked up when an analyst searches. Each approach has trade-offs, because ingestion time enrichment can make searches faster and more consistent, but it can also increase processing cost and can lock in context that might change later. Query time enrichment can reflect the most current context, but it depends on external lookups that might fail or slow down investigations. A mature approach often uses a mix, applying stable context like asset ownership and environment classification early, while applying more dynamic context like recent risk scoring or behavior baselines when needed. The key is to design enrichment so that it improves speed without making the pipeline brittle. For beginners, the main takeaway is that enrichment is not just a data science task. It is an operational design choice that must be reliable and secure. When enrichment is treated as part of the pipeline, it becomes a consistent force multiplier rather than an occasional manual lookup. As we conclude, remember that enrichment is the step that turns events into meaning, and meaning is what makes monitoring decisively faster. Identity context tells you who an account is and how risky it is. Asset context tells you what a system is and how much it matters. Network and location context tells you whether pathways are plausible, and baseline context tells you whether behavior is unusual. Enrichment also makes correlation possible, which lets the SOC connect scattered events into a coherent story without wasting time on manual mapping. At the same time, enrichment must be trustworthy and responsibly handled, because wrong or overly sensitive context can create new risks and new confusion. The highest return enrichment focuses on triage critical questions, especially around privilege, criticality, ownership, and normal behavior boundaries, because those are the facts that decide whether an alert is urgent. Over time, enrichment becomes a feedback-driven program, improving detections and improving response speed as the SOC learns what context matters most. If you can explain enrichment in this way, you can reason through monitoring efficiency questions on the exam and design telemetry programs that make fast, confident decisions possible.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.